All right, number 3. The figure pictured below is to have an area of 20 square feet. If I had to guess right off the bat, since the area is 20 square feet, this is probably our constraint. Area equals 20 feet squared. The bottom part of the figure is a rectangle and the top is a right triangle whose base is twice its height. So the bottom is a rectangle and the top is a right triangle whose base is twice its height, so 2a. Determine the value of the dimension a that will minimize the perimeter of this figure. So objective, min of perimeter. So I need a perimeter equation. And it looks like the variable is going to be a because there's lots of a's here. So I would just start here, perimeter, so h, then plus a. Ooh, now I need this right here. So to find the side of a triangle, I'd use the quadratic. So 2a squared plus a squared is equal to whatever that side is. I'll call it c. So 2, and I need to be careful with my parentheses here because it's 2a squared, which is a 4a squared, plus a squared equals c squared. So 4a squared plus a squared is 5a squared. And then I would take the square root of both sides, and that's square root of 5a equals c. Perfect. So I can finish my perimeter. I've got h and then a, and then the angly bit is square root of 5a, and then another h to go down, and then across here is another 2a. So I can simplify a bit. It looks like I have 3 plus the square root of 5a, and then 2 h's. So unfortunately I have 2 variables, so I'm going to need that constraint equation after all. So the constraint says that the area is 20 feet. So 20 is going to equal the area of the bottom and the area of the triangle. So I'm actually going to erase that because that's starting to look a little crazy. But the area of the rectangle is actually pretty easy. That's just going to be 2a times h. And then the area of the triangle is actually not bad either. That's going to be 1/2 the base, which is 2a, times the height, which is a, or 20 ah plus, let's see, a squared. So I need to use this constraint equation to eliminate one of the variables above, and I'm going to try to eliminate h. So I'll get h by itself with my constraint equation, and I'll subtract a squared and get 20 minus a squared equals, I think I have a small typo. I should have just a 2 there. All right. So I'm left with 2ah here, and I'll divide by 2a. And that gives me that h equals 20 divided by 2a, or 10 over a, and then minus a squared divided by 2a. That looks like just an a over 2. So this was a pause so that I could rewrite my equation with one variable. So my equation with one variable would be p of a equals 3 plus square root 5 times a. plus 2 times h, which is 10 over a minus a over 2, which is a little bit nasty. I'll try to clean that up a bit. 3 plus the square root of 5a plus 20 over a, and then 2 and a 2 cancels. I just get minus a. Oh, and that can simplify. So I have 3 plus the square root of 5a minus an a. So that's just 2 plus the square root of 5a plus, and I'll write this as 20a to the negative 1. The reason I'm doing that is I need to take the derivative and find the critical point, and it's a little bit easier to do that when I have a to a power. So derivative would be, so this is just a constant number. It's probably like 4 and a little bit, 4 point something something. So the derivative of a constant times a is just going to be the constant. And then derivative of the next bit is minus 20a to the negative 2, which I would set equal to 0. And I would add 20a to the negative 2 to the other side. So I get 2 plus square root 5 equals 20, and it's over a squared. Then I could multiply by a squared. So 2 plus square root 5a squared equals 20. Then divide by 2 plus square root 5. Get a squared equals 20 over 2 plus the square root of 5. And that gives me a equals the square root of 20 over 2 plus square root 5. So this is my critical point. The only trouble is I do want to make sure that it's the right thing. So I am supposed to find the minimum perimeter of this figure. So I need to check to make sure that it actually is the minimum. And I'll do that by taking the second derivative and plugging it in. So I'll do that right here. This is where I'm going to check. Second derivative, the constant would go away, and I would get plus 40, and then a to the negative 3 power. And actually, so mental math-wise, I can almost stop here. So the square root of 20 plus over 2 plus 5, all of that is positive. I know a square root has to give me something positive out. And if my derivative is 40 times a to the negative 3rd power, that's the same thing as 40 times 1 over a cubed. So if my critical point is positive, then this also has to be positive. So I know a has to equal the square root of 20 over 2 plus square root 5. Cool. Okay, if you have any questions, ask them on the discussion board.